So how many people here are designers? Cool. How many people are data scientists, AI? Okay, actually more than I expected, 3. So let's look at it a little bit differently. As designers, how many of you do some front-end development, some code, can toss down some CSS and HTML? Okay. How many of you can write a binary classifier machine learning algorithm? Cool. So 1, awesome. I'm here today to help convince you, or at least plant the idea in your head, that you might need to one day. AI, machine learning, deep learning, all of these different things, big data, are going to change design. But before we get there, let's go back in time a little bit. This is just honestly an excuse to put up a picture of my favorite movie. I want to look back about 10 years and at 3 big things that happened in 2007. So we all got iPhones, one early, or at least a few of us did. I worked for BlackBerry at the time, so I wasn't allowed one, but I got one eventually. Mr. Bieber, this is actually what he looked like in 2007, started putting videos on YouTube. That got kind of big. And then something else that happened that very few of us probably heard of was a guy named Yanif started a company called Face.com. Has anyone heard of him or Face.com? Yeah. So it was actually a pretty big deal that this happened. But we'll get there. A couple years later, his company was actually acquired by Facebook. So that was in about 2012. It was a closed deal, but they estimated that they paid somewhere around $100 million for the company, which is actually pretty cheap for what they got out of it. In a whole other part of the world, very disconnected from startups and technology, a very small firm called Lockheed Martin was working with this organization called the FBI in 2014, and they built something called NGI. NGI is what's called the Next Generation Identification System. So NGI was basically a facial recognition system. The FBI contracted Lockheed Martin, one of the biggest defense contractors in the world, a really good, socially responsible company, to build this for them. And it achieved roughly, and it hasn't actually changed much as far as is publicly known, roughly 85% accuracy in terms of doing facial recognition. Now, we as humans can do about 97.5, 98% accuracy in terms of seeing someone's face and knowing who that person is, assuming we have met that person before, of course. In 2015, a couple years after acquiring Face.com, Facebook rolled out something called Deepface, which is as creepy as a name as it is what it does. It's a terrible name. Deepface was Facebook's implementation of what they bought, the algorithms and the IP they bought with buying Yaniv's company, Face.com. My speaker notes actually right now say creepy name, creepier results. So, first of all, it worked a little bit better than the FBI system, which they spent, they've estimated close to $1 billion on. It's around 97.2% accuracy, again, as far as Facebook has publicly announced or published in some of the journal articles. It's basically as good as humans are. And in fact, in many circumstances, it's starting to outperform humans' ability to recognize faces, which is also kind of creepy. Here's where it gets awesome, and you may want to increase your passwords. They trained it with about 4 million images from 4,000 users. That was kind of the first training set to start training the machine learning algorithms. No one was told whether they were one of those 4,000 users, which is awesome. Somewhere buried in one of those agreements where you clicked I agree really quickly, you kind of said, okay, you can use all the pictures I've ever uploaded and all the tags I've done and learn from that. They do it with all images now, so if you use Facebook, you actually can't opt out anymore. Technically, for the technical-minded folks in the room, it's a 9-layer neural network. It's got about 120 million connection weights, so it's a very, very complex learning network. It's based on deep learning, which we will kind of get into a little bit. In terms of the training and the ongoing training, people are uploading 400 million photos a day on average to Facebook, which is a stupid number of photos. Every time we manually tag a photo, we are feeding information to Facebook, which further trains and tunes the algorithms to know who each face is. The really, really awesome part, again, for the more technically minded folks, you can represent the face in the form of a hash. It can be done in a 32-byte hash. So it's a very, very small amount of memory or computing space you need to actually store a hash that you can use to uniquely identify a face. So what does that mean? It means we can store roughly, if you do the math, 7 billion faces in 256 gigabytes of space. One of these. So all of this stuff is just kind of to introduce you to the concept of like where deep learning, where machine learning, where AI is kind of going. And it's pretty powerful stuff. How does it relate to design? We're going to get there in a moment. Let's just take a little bit of a step back. What is AI? AI is a term that was kind of first coined in the mid-50s, and then machine learning being kind of a sub-discipline or a more particular discipline within AI, also kind of the mid-50s. But essentially, machine learning is about the idea of finding patterns in data. In its essence, you can't really do a whole lot. You can kind of say, based on everything we know, we think this to be true. And that's all it really, really does. The power comes from the fact that you never have to explicitly tell the algorithm what it's looking for. So what does that actually look like other than a silly comic? Everyone read it? So the important part is that you never have to kind of explicitly explain what the boundaries are that you're looking for. So deep learning is kind of a subset of machine learning. It's based on neural networks. Typically, it's hierarchical learning. We don't actually need to really go into the details of what deep learning is, but let's talk about some things you can do. Image recognition. Figuring out if something is a cat or not a cat. The way that came up, I don't know why they were both displayed at the same time. A guy named Andrew Ning, who works for Google in their machine learning department in their deep learning area, was trying to figure out and tune some of their deep learning algorithms, and he said to himself, where are there a lot of images? Okay, YouTube. So they took a couple of million gigabytes of video from YouTube, put it all in, and just kind of said, look for patterns. And one of the patterns that emerged in this massive neural network that they built was a cat. Now, at no point did they have to tell the algorithm, tell the machine learning algorithms what a cat was or what a cat wasn't. It just kind of noticed there's these things that were cats and there's these things that were everything else. And you could actually, almost like the way an MRI works, where you can actually kind of see, or a functional MRI in your brain, you can see certain parts of your brain light up when different thought processes are engaged, or memories are engaged, or voice patterns are engaged. They could actually look at which parts of their neural network were lighting up when they fed in videos that had cats in them versus which ones didn't. So again, the really, really key part here, they never told it what a cat was. It just kind of noticed there's these things. The computer doesn't know what a cat is, doesn't know what a cat looks like, but can tell if something is a cat or not. Language and speech processing, Siri, Cortana, Amazon Echo, all these things are all based on AI, in particular deep learning, in terms of understanding. Lone default detection. It's a really, really cool case study. I'll talk about it because we've done some work in that. There's so many examples. It's all around us, but I don't think as a design community we've quite embraced the potential that AI, machine learning, deep learning, all these things can bring to us to build better interfaces, better experiences for customers, better physical, digital, kind of everything together. So that's what I want to go into today, is sort of looking at how can we take this information and do something more with it. I actually adore this quote. If we just look at the raw data and we can't make sense of it, it's like looking at the bare skin that's exposed, right? It's the machine learning algorithms, the deep learning lets us kind of go undercover. It's kind of a creepy analogy now that I put it up with this, but and try to understand what are the insights behind the data. So before we do that, let's talk about cookies. What is in Cookie Monster's hand? Come on. Someone, a cookie. How do you know it's a cookie? Because you've had one before. Nice. So you recognize a pattern in that cookie. So we're going to talk about cookie quality control, and we're going to use that to understand what machine learning is. In particular, we're going to look at one particular problem within machine learning, which is binary classification. So just like the cat example, is it a cat or is it anything else in the world other than a cat? We're going to say, is something a cookie or is something not a cookie? So let's we take 100 cookies, and we kind of made them sloppily, right? So some of them got too big, some of them got too small, and we want to sell them. So we won't count cookies that are too big or too small as sellable cookies. And in fact, we didn't really mix up the dough very well, or the batter. And so some of them have just way too many fucking chocolate chips, and they kind of fall apart. So those aren't good cookies either. And the ones without enough chocolate chips, they're no good either. So what we're going to do is we're going to take our 100 cookies, put them in a row, and we are going to, as cookie-making experts, go through and classify them. We're going to say which ones are good and which ones are bad. The red ones are the ones that are either too big, too small, not enough chocolate chips, no one will want to buy them, too many chocolate chips are going to fall apart. We're going to put those aside, and we'll mark those as not cookies. We're going to consider them to be not cookies, essentially a 0 on our cookie scale. And all the other ones that look really good, except for the ones we eat, we're going to call those cookies. We're going to graph them. So it looks like this. So we are going to feed this data now into an algorithm. I won't go into the details of what this is called a sigmoid function. I won't kind of dive into how it works or anything like that. But behind the scenes, what we're doing is something called a cost function. So we're saying, if we guess that something is a cookie and it is not a cookie, that is as wrong as we can possibly be. Like, there's no more wrongness than saying something is what it is not. And so a sigmoid function helps us understand if something is right or wrong. And what happens is using this training set of 100 cookies. Now, in fact, if we're doing real machine learning, we need far, far, far more data than 100. We need in the tens of thousands to train an algorithm. But for now, we're going to use 100. We're going to use a cost function. We're going to say, this is the boundary line. So now, anything that falls within this circle, essentially, if we graph out where this next cookie is by measuring it with a little tape measure and counting the number of chocolate chips that are visible, if it's within this circle, we know that it's a cookie. So this all seems really, really simple and kind of stupid, right? The whole point of this is that at no point have we told the machine what is a cookie and what is not. We told the machine there are these two things. Here's a bunch of one and here's a bunch of the other. And we did it 100 times. Now, on the 101st time, we're not going to tell it, is it a cookie or not? We're just going to give it this blob of baked dough. It's going to use a camera to take an image of it and count the number of chocolate chips, and it's going to make its own judgment of whether or not it's a cookie. That's the power of it. So this is a really, really stupid, simple example. What happens if we actually took it to the real world? So, who here has gotten a loan before of some kind? Cool. So you all know what a loan is. Someone gives you money. In exchange for that money, you pay them a certain rate of interest. Now, if you are a less reliable human being, you might pay more interest because the person lending you the money may not trust that you will repay them. If you are a very reliable person with a great track record, you may pay very little interest because the person lending you the money or the institution is sure that you'll pay them back. The idea here is, can we actually predict whether or not someone will pay back a loan? So Barclays, which is a bank in the UK, put out a data set. It had 100,000 records, and it had 800 variables for each record. Some of the variables were actually junk. They didn't tell people. They kind of took away. Imagine a spreadsheet, 100,000 rows long, 800 columns wide, and then they went and they were kind of dicks and they deleted the header row, which said what variables was what. They put that data set out and said, figure out which of these people defaulted on their loan, which ones paid back their loan, and the ones who defaulted, by how much. So this is kind of what the data looked like. So we know there are two types of people. We ended up finding out that about 10% defaulted. The objective was to figure out which people defaulted and what was the loss. So by how much did they not pay back their loan? We had 800 variables to go through. Using the 100,000 records we had, we were able to train the deep learning algorithm. We got 99% accuracy on predicting whether or not someone defaulted or not, and about 96% accuracy by how much. So what happened was we put the 100,000 records in, we trained the data set, and then we were given another set of data which didn't tell us the answer, and we got another 10,000. We tested this against that final 10,000. So we got pretty good results, and now you can start to see why this matters. For an organization like a bank, this is incredibly valuable. Now we could actually know in advance what interest rate to charge someone. We are going to bring this back to how to design better interfaces. The really, really cool part, which I will just briefly share, is we discovered that only 6 of the 800 variables mattered to a significant degree. So if we took all 800 pieces of information about a record, we got a 99% chance of guessing right. If we took the right 6 variables, we earned about 97.5% accuracy. So with a lot less information, but the right information, we are able to get still very, very good results. I'm not going to talk about the topological data analysis. I meant to hide this slide. It's a really cool looking slide, so it's pretty. Basically what it says, though, is that that 96%, so our accuracy on how much we defaulted by, it kind of starts to break down when we started moving out of like car loans in the $10,000, $20,000 range, and we got to mortgages for the $400,000 range. So if we actually separated out a few categories of loans, we got much better results. The second we had very mixed data sets that had such a broad range of loans, it was really hard to get the accuracy high. Okay, so what does this all mean for designers? I really, really think you guys need to either start learning some of this stuff or just buddy up with your in-house data scientist or machine learning engineer or whatever it happens to be. There's a few things that I think are going to change in the design industry, especially from the UX and experience side. I do really think that the same way having an understanding of CSS, HTML, front-end development is a huge asset for designers now. I think we're going to see the same thing for having a fundamental basic understanding of data science. So it doesn't mean you're going to have to start writing your own algorithms. That's probably not what it is. But it means you're going to have to be able to help understand them and make meaning of that information. I think that requires a basic understanding of some of the math behind the scenes, some of the psychology, the sociology, maybe even one day biology behind all of this data science stuff. I think we're also going to start seeing much faster iteration loops, especially when we start connecting quantitative and qualitative research. So one thing that data science helps us do is really, really amp up our quantitative research. So we can start getting much deeper quantitative insights about what we're doing. But the one thing, and we're going to come back to this, that the numbers can't tell you is why. So you can dig into data, you can look at A/B testing and really, really advanced sort of testing like that, and start putting analysis on it and start finding patterns and insights and realize, hey, you know what? People choose the B version of our homepage over the A version when it's sunny weather. Great, the data can prove that out beyond a doubt. You can start changing your designs as a result. You can have your homepage actually dynamically adapt based on whatever the weather forecast is at the IP address that your user's from. But you still can't figure out why. And that's where the qualitative research comes in. So I don't think this is the end of any of that by any means. I think that we're going to start having really, really fast iterations between quantitative and qualitative research. The cool thing is, just like that example of changing your homepage based on the weather, we're going to have really, really, really adaptive systems. And we're going to talk about some examples. So what's the difference between an online course and a teacher? Would it be fair to say feedback? Yes. Yeah. So a teacher is a built-in feedback loop. In fact, just for fun, I just started tutoring high school calculus to a friend of mine a couple of weeks ago who has to get their high school equivalency for calculus. And she's very, very smart. And this isn't even really part of what I was planning for the talk, but it kind of happened and it lined up here. She could do these problems, but the second the problem was asked sort of in an application kind of way for these very, very basic calculus problems, she really struggled. And I realized that the online course that she was taking never explained to her what calculus was. The online course couldn't tell when she was frustrated, and it couldn't tell whether she understood the core concepts All it could do is kind of show a pattern of this problem, you solve it this way. But the second the question was asked differently, she really struggled. So, stock photo of a teacher and a student, lovely. Random stock photo you find when you type in online learning stock photo. Feedback loops are really, really different. So while I was actually spending time with this friend of mine, I had this idea, which I don't know if anyone's actually done this yet, but what if your online learning system could actually give you some of the feedback that teachers can? So there are self-tests and self-assessments, but I think those are too late because we've now taught you something, supposedly, and then we test whether or not you learned it. What if the system could actually figure out if you're learning it as you go? One of the areas of research that we work in at Architech is, in our lab, is emotion detection. So that's looking at someone's face through both still and video content and trying to understand what the emotional feeling is behind that. So are they frustrated? Are they happy? Are they elated? Are they horny? Like whatever it happens to be. I don't know if we can do that last one, actually. So what if you could embed that in? What if you're taking your online course on your iPad or your laptop and the camera's on, yep, creepy a little bit, but it's actually watching your face and watching your behavioral response to reading, to watching a video, and it gets to a point where you suddenly exhibit the patterns of someone who's frustrated. And now it takes a step back and tries to explain the same concept to you in different words. Almost like a choose-your-own-adventure story, which, by the way, are totally making a comeback, because I just bought a copy of Romeo and or Juliet, which I haven't read yet, but I'm really excited about. All of this comes from machine learning and deep learning. The idea of facial recognition, we can only do that as a result of massive data sets of people who are smiling and happy and people who are sad and upset, training systems with that information and then learning from that. So it's actually just one example I kind of thought of from my own personal circumstance where we can start building better interactive digital systems using some of this intelligence that we have. Let's talk about a different example. Go. Oh. What about the travel industry? Does anyone recognize this site? It also says Airbnb on it, so I won't make you guess. We did some work looking at Airbnb, and again, they released a data set to us that we got to kind of play around with. So the idea was, can we predict whether or not a user is going to book, a new user who does not have an account, whether or not they're going to book, and which country they're going to book in? So, you know nothing about me. If I went to Airbnb.com, what country would I book in? Anyone want to guess? Maybe. There's very little way to know on an individual basis, but what ended up happening was we were given records for 200,000 first-time users. We were given 20 observations about those users. And then for those 200,000, we were told whether or not they booked and what country they booked in. So that was the training set of data we got. We got to build out an algorithm based on that training set, and then we were given a smaller set of data, which is called the test set, where we then tested and said, can we now guess for number 200,001, can we guess where he or she will book and if she will book? What we ended up finding, and so these are some of the variables we're given: age, account creation date, gender. We were actually given the weather on the day that they created their account, their sign-up method, their inbound referral link if they had one. That's the type of information we got, times 200,000. We found that actually only 12 of the variables mattered. And does anyone want to guess within what accuracy we guessed their booking country? After the 99% thing, you want to guess really high. It wasn't quite that high. It was about 87%. But that's still badass, because now someone who does not have an account on our site and we have only basic information from when they create their profile, we can start, or Airbnb can now start to create very, very specifically targeted content for them. Without having to ask them what country you're interested in booking in, they can actually get the best guess. So when we actually looked at what are the top 3 countries they're likely to book in, we were in the 96% range. So if we're going to put up a homepage, which, keep in mind, looks like this, which generally has kind of that tiled interface at the bottom. My last booking happened to be in Spain. So Imagine that the 3 that you see on the landing page are the 3 countries that you're 96% most likely to book in. And imagine what that does to conversions, to user experience, to the overall brand, as well as to the business side of things. That's the power of machine learning and AI when it comes to design, is that we can start using this information to create more tailored, more meaningful, and more impactful from a business sense experiences. So I'm going to share one other example, and it's something that my team's working on right now at Architech. It's kind of both digital and physical. Does anyone recognize this store? You may or may not. Yeah, it's a Sportchek. We do a fair bit of work with Sportchek. I was actually in Calgary with them earlier this week. This is their shoe wall. When someone walks in looking for shoes, again, unless we happen, as a store representative, unless I happen to know that person, I really have no idea what shoe they're looking for. What if we start feeding in data and we start looking at patterns in users' buying behaviors? For example, time of day, time of year, weather, upcoming events, gender, age, by the way, which both from a simple picture of someone's face, gender and age, you can guess in the like high 90% accuracy. Gait, which is a really interesting one. Your gait is your footfall behavior. And some people are pronators, some people are supinators. The idea being even just what clothing they're wearing. If they happen to be decked out with Nike logos all over their body. The idea being, can we recommend the right shoe to a customer before they even know what the right shoe is for them? And not just what's the most expensive shoe or what's the shoe that we're trying to push from a marketing perspective, but what if it's a shoe that is actually best suited for that person's specific footfall behavior or their body type? That's the idea behind this. So when we start combining behavioral data, history, and then kind of external forces like the weather or upcoming events, things like that, when you're about 3 months before a marathon, one of the big city marathons, every running shoe store in the world has an uptick in running shoe sales. Because that's roughly when people start training, usually kind of on a 14 or 16 week pattern, start training for a marathon. So they go and buy new shoes. So what if we can now in the store take information like that, take information like this from overhead cameras, and start actually predicting what product someone's looking for, and then giving both in-store associates a leg up on terms of what customers are looking for and helping them give better recommendations, but also the digital systems in the store, which if anyone's been in a Sportchek lately, like they're all screens. The Sportchek at Sherway Gardens, which is their new flagship store, has 743 LCD and LED panels in the store. It's kind of obscene, actually. But it gives you an idea just how much digital is happening in the store. And so what if each of those systems is now tailored that's going to show you the best product for you at that time? Can it change conversions? Can it make it a more delightful experience to go into that store? Can it help a physical store like Sportchek, which for some reason doesn't really do e-commerce yet, compete with the Amazons and the e-commerce platforms out there? So again, I think that designing, whether it's physical store layout, whether it's organizational design of how your employees work in your store, or whether it's digital design in terms of what the interfaces are like in that store, all of them have so much potential to learn from people's behaviors and learn from the machine learning and the AI that we have as technologies now. And that's kind of what I'm most excited about, to be honest, because it's a world that's kind of changing every day. It gets me really pumped up because there's so much cool stuff we can do. So why do we need to adapt? Let me find my other notes here. There's probably a couple of counter arguments you guys are thinking about here when we talk about sort of data-driven or insight-driven design. So the first one is data can only look backwards, right? We can look back at the first 200,000 Airbnb users and be sure of it, but 200,001, we're making a guess looking forward. It's absolutely true. And that's why we kind of always have to be validating as we go. And that's where the qualitative complement, I think, to the data-driven research and the data-driven design really, really comes in. Does anyone know about Google's 41 Shades of Blue experiment? Yes, I'm nodding along. So Google A/B tested 41 Shades of Blue to create the optimal blue for conversions and click-throughs. So that is pure data-driven, insight-driven design. A lot of people would make the argument that is a very tactical thing, and it's not at all strategic. And yeah, you're probably right. It's not actually creating the experience, it's tweaking the experience. So I think that the role of the designer isn't going away anytime soon. The final argument against sort of this approach is that it only skims the surface, right? None of these things can tell us why. So we did some work, which is, it's not really that design heavy, but we worked with a commercial REIT. Actually, they own this building. It's called a company called Dream, so they own commercial properties all over Toronto, all over Canada. And we started looking at all of their data in terms of lease renewals. And they just always assumed that people on the highest floors were the longest lasting tenants. And we started actually diving into the data, and this was not a whole lot of AI involved in sort of finding these patterns. We actually found that people in the the 25 to 50% up, highest floor in the building, were the fastest ones to leave. Why? We have no clue. We actually don't know why. We know it to be true, and we can adjust so they can, for example, start doing kind of like a churn prevention program, right? So they can go to people who are in the floors of their building at the exact time in their lease where they're most likely to maybe decide to move, and offer them a new renewed lease at a better rate or the same rate or not increase their rent, things like that. So they can start to adapt their behaviors. But figuring out why that is, it's a whole other ball game. That's, again, I think where the designers and the human touch comes in. So by no means is this a replacement for design, as much as this company would love to have you believe, which, go, Siri, play. So this is a company called thegrid.io. Has anyone heard of the site? I don't even actually, so not getting a lot of audio, but it's supposedly an AI-driven website design platform. So just like Squarespace and a million other like GeoCities way back when to help you build your own websites. But this one here supposedly does all of the design through some of their AI based on best practices of what design patterns, what color palettes, things like that are most resonant in the industry you're in, the type of content you're uploading into their system. And it does the layout, it does the colors, it does typography all for you. Now, they launched as a beta a couple of years ago. Had a bunch of people become founders for $100 memberships. If you actually Google or like look at Reddit or anything like that in the last like 3 days, their stuff doesn't work super well yet. But I'll argue that it's the first company trying to do design based on algorithms, that they're doing the entire layout of these sites dynamically based on best sort of learned behaviors from other websites. So it is a really cool concept. It is really early days. It's no different than, you know, Elon Musk saying, I'm going to build an electric car, and all the car companies being like, dude, that's never going to work. I think that this is where some of this stuff is headed. So look out. The algorithms are coming for your jobs. And I think that the best way to, I'm not going to say mitigate against that, we're not quite at risk yet, but I would say that understanding what AI is, what machine learning in particular as a subfield of that is, and how it relates to design is a vitally important skill. So this is actually an article written by one of the guys from Huge, in a really great article just about design and AI in general. And so AI allows designers to cater to, anticipate, and kind of adapt to an individual's needs. So rather than building for the masses, we can start to think about an individual's particular needs. So imagine bathroom mirrors that adjust the lighting in your room or in the bathroom based on stress levels. There's just so many possible impacts to knowing a little bit more about your individual user, where you're now not designing for a persona or a market segment or an archetype of a user, but you actually can now adapt your design to a particular user. That's what's really exciting to me. So I think it's a good thing that's coming this way and the way technology is adapting, and I'm pretty excited to see how design becomes a complement to the power of all this data. So that's it. Any questions? Yeah.
So I work for One Password, and one of our kind of founding principles is that we do not track anything. Everything that we see about every person is encrypted.
Yep.
I love the idea of data science, and I actually married a data scientist, so So they are the people that say, I love your product, I hate your product. We rarely see anything in between. Do you think there is a way of using kind of machine learning to find the middle between that?
It's a really interesting question, and you're in a tough industry, and I'm glad to know you don't track anything. I like 99% believe you that you don't, but I'm not saying you do, but you never know who else is listening. It's a really tough one, right? It's not that dissimilar from the way reviews even happen online. To make sense of an online review, and there's actually a few companies trying to do exactly this problem. If you look at Amazon reviews, or App Store reviews, or anything like that, the distributions are actually not normal human distributions of how happy people are. They are 80% 5-star and 10% 1-star, and for some reason that middle range, which is actually how most people feel, ends up being roughly 10 to 12% of online reviews. So there's a few companies trying to work on that, but I think it actually implies a behavioral change too. So when I take an Uber, if I have good service, and I think I'm probably the only one, I rate it 4 stars, because I think that's good. Who here rates it 5 stars when they take an Uber and have good service? Yeah, that's kind of become the default behavior. To me, 5 is like the one weirdo who had a cappuccino machine in his car and made me fresh coffee. I'm not actually directly right on King West not too long ago, and drove like a huge Audi SUV, and a little weird, a lot weird, but that was 5 stars to me. And I find that I think it's more of an organizational or sort of a behavioral change that you're talking about, which I don't know that data can totally do for us, but there are a few companies trying to do, for example, I forget the name of the company, but what they're doing is they're looking at Amazon reviews and using NLP, which is natural language processing, which is making meaning out of words, right? Our brains are really good at it. Computers are notoriously bad at it. It's really hard to do. Doing text-to-speech is easy, right? These letters make this sound. That's easy. But these words together mean this information is actually a very, very difficult problem to solve. They're doing that right now on reviews on Amazon, trying to actually figure out what the meaning reviews are, and out of the 5-star reviews, which ones are actually positive reviews, which ones are more neutral ones, things like that. So there's a few people looking at it, and I think that's probably one of the ways is to, for example, look at the content of it. All over the world, banks, cell phone companies, anywhere where there's a big customer service center where you phone in for customer service center, they are now all doing that too. So they are doing voice to text conversion and then text to meaning conversion using NLP to try to understand the meaning of customer service experiences so that they can now start to tie in, hey, this customer service rep, regardless of what the surveys, when you call in the Rogers or whatever and they ask you to take a brief survey at the end of your call and no one ever does it, what if we could actually tell from a person's voice patterns if they're angry or happy or frustrated at the end of a call? They're starting to tie that back to individual customer service reps. Again, trying to make meaning out of that middle range of people from some of the more subtle insights that are in the content. So I think it's diving into the content of those emails and trying to make meaning of it. But it's a huge, huge problem.
Yeah, the way we actually solved it was to put everybody on customer service for 2 hours a day.
Oh, sure. On your side to have everyone get a feeling for it. Totally. Yeah.
I have a kind of social perspective question.
Sure.
Something in the Atlantic the other day about facial recognition software and AI reinforcing racial bias. And so I was wondering, what do you as data scientists do when training reinforces social inequities, or do you know of any folks who are working on this issue?
I don't know of anyone working on it, but it's hugely a thing. You can find patterns, we've done this, our facial recognition algorithm software can do an age and gender, and they can totally do ethnicity detection. It's just a thing you can do. And I have no doubt that you could find patterns let's say Sportchek, if we put cameras, which we don't do yet, but if we put cameras in all Sportchek stores, we could find 100% racial patterns in people's buying behaviors, people's browsing behaviors based on race. I personally don't know if it's... Now, that's not creating necessarily an inequity. That's just using more information about a person. I'm personally really, really mixed on it because there are things that are just yes, this person with this background has a different buying behavior. That's not a bad thing necessarily, just this person is male and this person's female and they have different buying behaviors. When it starts to target people, I think it becomes really challenging. I think the biggest problem we have with all of this is that the technology is leaps and bounds and accelerating much faster than either the ethics side of it, the sociology, the ethical side of it, as well as the legal side of it. So Sportchek could, we've talked to them about this, they could put up cameras and start doing this targeting stuff. We're not doing it yet. Legally, they could do it. The second they did it, they're going to have a target on their back for doing this stuff. So from a brand PR perspective, it would be a massive nightmare, but legally, there's nothing stopping them. So I think that the bigger problem we have, which is a part of that, is that the ethics sides, the legality sides of all this stuff is friggin' slow to move ahead. And there are researchers in Facebook's labs and Microsoft labs and Google's labs working on this stuff so fast that they're not going to slow down either. So I don't actually have an answer for you. I don't know if you have an answer. Like, what do you think? But
I was just curious.
yeah, it's...
I learned about the ethics, and so that's why I was curious. Like, do people talk about this? Are they working on this? Is this part of people's teams? Like, I don't know.
Yeah, like one that someone proposed back to me, someone said like, they challenged the loan default protection or detection thing, and they said like, well, that's not fair. You know, everyone should have the same right to a loan. I was like, fuck no. Like, no, if I'm giving you my money, I think I have the right to as much information that gives me certainty about whether or not I'll get my money back. Like, actually, maybe that's a bit of my slightly capitalist side, but I think that that's fair, right? Because it's my money. So a lot of this stuff is still kind of being figured out, and a lot of room for good debate. There's one question just behind you.
Within the same line of the previous question about where's privacy on all of this?
Yeah, so for example, you don't need to connect someone's identity with their identity. And that sounds really silly, but like, for example, let's say, again, Sportchek as my example, I want to have a person walk in the store. I want to know as much as I can about them to give them the best possible experience. And let's be honest, to sell them the most stuff. Like, let's not hide the end goal here. I don't actually need to know their name. I don't need to know anything really about them as a person. I just need to know sort of what category they fall into. So there are ways to remove the personal information from it. Same with the loan side of things, but I think it requires sort of a concept that one of my coworkers used to always advocate for, which is privacy by design. That the privacy and the security of the information is actually thought ahead of as part of the solution that you're designing. It can't be an afterthought. In what way? Like, so what's the...
facial recognition, that's basically a personal information. It's like grabbing a picture of your own face, you know?
Yeah? Do you...
Even if it's not your name on it.
Yeah, so for example, the stores would have to tell you that they might be using it, but right now there's nothing against using it. I'll give you like a really scary example. There's a prof at a university just outside of Maryland, I forget what school it's called. He got himself arrested by the NSA. They came to his house when they found out what he was doing. Nothing illegal technically, but at first he was looking at social security numbers, so it's similar to our social insurance numbers. And he noticed kind of that there's a pattern in it, and the pattern related to birth date, so month and year of birth in particular, and birth city. It wasn't 100% accurate with those two pieces of input. He couldn't necessarily guess, but he could get like 6 digits like 85% of the time on someone's SSN. Then he thought to himself, well, where can I figure out someone's birthday and place of birth? Facebook, easy. At the same time, Facebook was starting to do some of their facial recognition stuff. So he actually built himself a little app in test flight on an iPhone, and there's videos of him walking through the streets of Baltimore and in DC, asking people that they're doing an experiment, none of the data is saved, but they're just testing something. And they ask people to take this phone and take a selfie of them. And they take a picture of themselves, and it pops up and says, is this your social security number? Pissed a lot of people off. Again, it wasn't 100% accurate, but like you saw enough pattern, you're like, that's pretty damn close, and that's scary. And that's without really tuning the algorithm. NSA heard about it, came to his door, arrested him, searched his home. It was a pretty crazy outcome of what happened. He now works contracts for the NSA, which is incredible. Probably charges him like $1,000 an hour at least. Again, the laws aren't there yet. Like nothing he did was actually illegal. He took public information that someone willingly gave, their photo, guessed who they were, looked them up on Facebook, and took a guess at their number. So again, it's the same answer of we need legislators, we need, I think, communities to advocate for some of the rules coming into place and making it fair. But I also think we as designers need to be advocating for privacy by design and making that a part of the solution. I wish I had a better answer, like, here's the answer, but I don't. So I think that's, oh yeah, sorry.
Is there anybody that's doing research or implementations of this type of thing where people want to donate their information to get a better experience, right? Like, for instance, I have no qualms sharing who I am, my current demographic, what my demographic is in regards to job position, history, education, all that stuff, in order to get myself discounts, better targeted product information, all this stuff, and better service altogether. Is there anybody that's interested in that type of thing in the industry?
Absolutely. That actually I did a workshop for a bunch of banks and then a bunch of fintech companies all together and kind of debating a lot of these topics and talking about like blockchain and all this stuff. But we also had a panel of high school students as a part of this workshop. And at the end, the panel of high schools came up and all these like bank VPs were asking them questions. And as an aggregate, these were very educated, these were like IB students, very educated, young, like 15 to 17-year-olds. They all kind of felt like, if I'm getting something in exchange, no problem. I also watched one of these students correct John Ruffalo, who's a pretty big deal in the finance industry, about how blockchain works, which was awesome. And I watched one of them tell the CIO of RBC that if they didn't change the way they did things, their bank wouldn't exist in 20 years. It's amazing. It was the best day. But yeah, I think that eventually we will get to a point, just like your email address used to be a thing, right? You'd go into a like H&M or something, like, oh, give us your email address and we'll give you 10% off. The next one will be, can we take a picture of your face and we'll give you 10% off.
When you walk in.
Yeah, could like choose to identify yourself. There is the counter side to it. Saks Fifth Avenue is doing something really fucking scary. So their cameras, and I'll finish after this because I see Alex staying there. Their cameras for security are all facial recognition enabled. If you get caught stealing something there and like walking out the door, they'll jump on you and the security guy will tackle you and whatever they do. And they will threaten to prosecute you to the fullest extent of the law, all this stuff, or they'll say, or we'll let it go, but we're going to take a picture of your face. People would probably choose to not get in trouble, especially like a first-time shoplifter or a kid or something. But now imagine the fact that when you give away your face, and I have a friend who works there, and I won't say names, but I got to see what people actually sign. It gives Saks the ability to sell that picture. So it means now, theoretically, they have this data that is so valuable because they have the right to your face. And now they can now essentially feed that into the cameras at all of their stores and any other store that is willing to pay them for their highest, most capable security system of all time, which can pre-identify a shoplifter. And in theory, remember, you're on their property. So a store could just say, like, your face comes up on the camera that's at the door. They could just walk up and say, I'm sorry, you're not welcome in our store because I know you once 10 years ago shoplifted something from a Saks Fifth Avenue. So again, racial biases, individual biases, people make mistakes. There's so much crazy stuff here. All of what they're doing is legal, and mostly because very few people have thought of it so far. So whether that changes or not, I hope so, but that's a really, really scary one. So anyway, I think that's time. Thank you very much for the debate and the conversation. I appreciate it.